First thing we are going to do is I observe that here I have a power of base 3 and a power of base 2. And I can transform this power of base 4 into a power of base 2. Because 4 equals 2 squared. And I can write that this is 2 squared to the power of x, so I can multiply the exponents. This would be my first step. And then I copy the other equation. The best choice here, it is to change the variable, all right, because it would make things easier. So I will call 2 to the power of x will be a for me, and 3 to the power of y will be b. And now we are going to rewrite the equation using these two new variables. So this would be a squared, right? Then plus, when I have an exponent subtracting, I can transform this into a division, right? Because I can say that this is 3 to the power of y, that is b, over 3 to the power of 1. Because I'm going to explain this with more detail. This would be 3 to the power of y over 3 to the power of 1. Observe that when we divide powers of the same base, we subtract the exponents, and this is the same than this. Let's go on. If the exponents here, I have an addition, I can transform this into a multiplication. And it would be 2 to the power of x, that is a, times 2 cubed, that is 8. And then another addition here, so I can transform this into 3 to the power of y, that is b, times 3 to the power of 1, that is 3, equals 5. Let's organize this and let's solve this system of equations. I would have 3a squared, because I'm going to multiply the whole equation by 3, so I get rid of this denominator, plus b, and 3 times 19, that equals 57. And then we organize this, 8a, we usually place the number before the variable, minus 3b equals 5. Now, what we are going to do is I'm going to make this b disappear, like an addition elimination, although this is not a linear system of equations, but we will have an equation just with the variable b. So we are going to multiply this equation by 3, and when I add them, variable b will disappear. Let's do it. I would have 9a squared plus 3b, and then 3 times 57, that equals 171. And I leave this equation how it is. Minus 3b equals 5. I'm going to add these two equations together. I'm going to do it here, that we have more room. So 9a squared plus 8a, they cancel out, and then plus 176 equals 0. And now we just have to solve the second degree equation. Sorry, this is not correct because 176 would be here, but if I place it here to organize the equation, this will be a negative sign, and now it is correct. So a with b, we have to use the second degree equation formula. Minus b, minus 8, plus or minus the square root of b squared, that is 64. Minus 4ac, so it would be positive because a negative times a negative is a positive, and if we multiply this and 4, we would obtain this. Over 18, that is 2a. So a equals minus 8. The result of this root is 80 over 18. So we obtain two results. Minus 8 plus 80 over 18 equals 4. And the other would be minus 44 over 9 when we do minus 8 minus 80. Now we have to undo the exchange of variable. And we have that 2 to the power of x equals a, in this case 4. So the exponent must be 2 because 2 squared equals 4. And if we try with this one, 2 to the power of x equals minus 44 over 9. There's no possible solution for x here because Although I place negative values here, the result will be always positive. So this is not valid, this solution. And now I have to find y. Well, first I have to find b with this result, and then I will find y. To find b, we have to go to an easy equation. Like, for example, I would use this one. So 8a, so 8 times 4, it is 32, minus 3b equals 5. If I work with this, I would have that 3b equals, it goes to the other side subtracting, minus 27. So b would be 9. And now, once I have b, I'm going to undo my exchange of variable. So 3 to the power of y equals b, that is 9. In this case, y must be 2 as well. So this is my answer to the system. I hope you understood. Bye.